crawl spaces and foundations in general in Southeast have a pretty tough job to do. You've got lots of rain, you've got saturated soils. In many cases you have a high water table. That means the groundwater is very close to the surface, and many house sites have very poor drainage. What we're going to explore is how you can increase energy performance in a crawl space in an existing home in maritime Southeast Alaska and deal with some of the moisture issues. And as a special guest, we've got Markham George, the Associate Professor of Construction Technology at the University of Alaska campus in Southeast, and he's going to give us a lot of pointers on what he's seen and what he's been able to make work in crawl spaces in that region. Today, we're going to talk a little bit about crawl spaces in cold maritime climates. You've just got major water problems that you have to contend with one way or another, it sounds like.
It's not uncommon to have 8 inches of water or so in standing water in a crawl space, or uncovered soils and just evaporating moisture into the building. So if we can decouple the foundation, the ground contact of our building into our building enclosure, that's going to be a lot better durability and for the occupant's lifestyle and comfort.
So what we've got here is a 1970s home. It's fairly typical for a home built in that era. It does have some moisture issues, so we're going to take a look at this crawl space and make some pointers and take a look. This looks like pretty good reverse drainage there.
Sure does. This is a block wall. It doesn't appear to have any damp proofing on it. It looks like we have, a low spot around the perimeter. This is a real recipe for recirculating and recycling exterior water back into the crawl space. We need to make sure we keep the ground a minimum of 6 inches away from wood to meet code. So there appears to be enough room that if you want to increase the fill around the perimeter.
And we've got almost 2 full courses of blocks, so you could probably fill up to here, and that would give you enough grade. By the time you went out 3 or 4 feet, you'd have real good drainage.
Often we run across sites and lots that just don't allow you to have grading all the way away from the building, so we'll end up creating like a swale, kind of capture the water and direct it away from the foundation itself.
Oh, so you would build up a little bit and then create a channel that flows out on the outside. Somebody's got a sump pump in the crawl space. They're trying to deal with some of the water issues that way, but I'd say it's got to start with good grading. You can stop a lot of it right there.
That's the best practice we can do.
So here we've got what looks to be about 32 feet of roof that doesn't have any gutter at all. Probably the snow took it right off. So this is an area especially vulnerable because the grading is towards the house. So 2 obvious solutions here right off the bat would be to fix the gutters and grade the soil away. I mean, anything you can do out here to stop that moisture intrusion into the crawl space to begin with is going to be huge as far as peace of mind and stopping potential problems later. What we're looking at here is a very old vapor retarder. It's got lots of holes and tears in it. And we're seeing some wet soils underneath here. Obviously there's a lot of moisture coming into this crawl space just by essentially evaporating right off of the ground.
The ground surface is dry only at the surface, and then right below there, 1/2 inch, it's wet, and we're just seeing evaporation off the top of the soils. Indoor air quality and building durability probably are our 2 biggest concerns as we deal with how we connect to the wet ground.
Okay.
As we have that driving force, more moisture is going to be absorbed by your wood building materials.
Yes, and so they need the ability to dry in wintertime.
Yeah. It's just drying is such a difficult part of building materials in Southeast Alaska.
Realistically, when we replace this ground vapor barrier, what are we looking to do, Markham?
Ideally, the vapor retarder of the crawl space should act as a swimming pool liner. I'd like to see it come about 6 inches above the top of the footing, be air sealed and compressively sealed to the foundation stem wall. A minimum of a 6-inch lap joint on any seam within the vapor retarder. Ideally, to seal it up with something like an acoustical sealant and then tape those joints.
Our goal with this ground vapor retarder is to minimize the number of places where you have exposed soils or wicking potential from this block, and that's what we're seeing here. As we've got a concrete footer and there's a post set on top of the footer, and this is a place where if there's enough water in the ground underneath, capillary action will take water and bring it all the way through and carry it up into the bottom of this post. It looks like recently someone's already replaced this post once, and so someone's taking care of it, and there is already a membrane here that's acting as a water break underneath here. But good materials in this case would be an asphalt shingle, and that could be stuck underneath the post or underneath the plate here carrying the post, or a scrap of EPDM rubber could be cut to fit around the perimeter. Leave enough around the edges that when you wrap your ground vapor retarder strip over this footing, you can tie the two together. Unfortunately, this plate's already been bolted down into the concrete. Ideally, you'd be able to jack this post up a little bit and slide the new membrane underneath and then tie everything together that way.
Okay. And that way we just tilt it up there and roller hammer through.
All right.
Well, I think that if you come up above the block, tipped or above the footing, that's a cold joint, so that's a weeper. So if you could easily have water transmission right through that joint
along
there.
this spot where the wall meets the footing.
So I think going above about 6 inches up above would be my first choice.
So here we've rolled out the large surface part of our ground vapor retarder, and we've cut it just along the edge of the where the soil meets the footer. And now we're going to attach the strip that goes about 6 inches or so up the wall, and that's going to make the transition for us. It's just easier to do it in one small piece rather than taking a large sheet and trying to fold it on all the corners. Sometimes you get buildup in one place and not enough in another, and this here avoids that. In order to seal the poly to the block, we're using Tremco acoustical sealant. It's got good long-term adhesion, doesn't harden, so it's a great sealer for this type of application. And we're running a nice fat bead so we can hopefully bond in with any irregularities in the concrete, give us the best possible seal.
Go to board the top of block, the first block.
Okay, so we'll just go to the joint,
Yeah.
the lower joint there.
Yeah.
Go your way a little. There we go. Just a little more coverage. A little more there.
It's important to tape these down so that you don't keep the poopy right long. Look at this, how black this is over here.
So what we're seeing here is clear signs of air leakage traveling through the rim joist and through the joint between the sill plate and the block. There was no sealer used when this house was built, and so every place you see a dark spot like this where there's been insulation contact, you can see that the air has been leaking in, and any dirt in that air has been getting deposited in the insulation. So what we've done, taken this out here, and this is black. There's been a lot of air movement. Potentially that air has been coming through from the outside, getting through at the joint up here between the subfloor and the top of the rim joist. It could have also been coming in through under the sill here. This wasn't sealed adequately. And I suppose it's possible, looking at the gaps between the joists here, that you could have had some air moving behind the joists as well. The goal here, of course, is to seal this whole area with a piece of rigid foam board and caulk it in place, or spray foam it in place, and that should address all those leakage issues. And this sill here could be sealed with foam board as it goes against this plate.
Many of our rim joists have rotted down in Juneau over the years because of the fiberglass in contact with the rim joists, getting it cold, but it's still allowing air leakage against it, and then condensing and then holding that moisture like a sponge might. For over 10 years now, the City and Borough of Juneau has not allowed fiberglass insulation in contact with the rim joist that's connected to an unconditioned space. I think we're just going to try to beat it right in there.
As we're going along and insulating and air sealing the rim joist with 2-inch foam board, we've come across one of these foundation vents that was put in when the house was built. Now what we're trying to do is air seal this crawl space and make it airtight, so we're actually shutting this vent.
For us in Southeast, mechanically venting a crawl space works so much better typically than asking for passive ventilation to occur.
So what we're doing here is we're going to seal this air vent up with insulation, treat it the same as all the other rim joist bays, and then we're going to mechanically vent this crawl space rather than depending on natural air leakage coming
Right.
or going. There's a couple of different ways to do this. You can cut the foam blocks to fit really snug and then seal around them. In this case, we're using a foam gun to do it. Or you can cut the blocks a little bit loose and have a gap and inject the foam into that gap. In either case, though, you want to attain a good air seal all the way around the perimeter. Granted, this is a lot of work to do this in a crawl space. I think it's well worthwhile talking to a spray foam installer and seeing if they could install some high density spray foam if it's price worthy.
Here we have a 2+ inch diameter hole from the crawl space. All houses suck. They suck from any hole that's possible because they're going to find equilibrium. How often are you going to find a 2-inch diameter hole all the way through the wall or the ceiling? So the better we can seal these holes up, air is still going to come into the house, but we're going to perhaps find a better spot than the crawl space.
We're going to jam this here into this oversized hole in order to air seal a little better. We've managed to jam this up about 3/4 of an inch into that oversized hole, so that will air seal nicely. And now we can spray around the rest of it and fill any remaining gaps. Not pretty, but the idea is this pipe can still move up and down a little bit inside this sleeve, and you're not going to break that air seal joint that the spray foam's created. Once we've gone around the entire floor perimeter, both in the joist bays here and along the long edges of the floor, and sealed all that with foam board and air sealed it with spray foam, we've gone back in and filled the joist bays with fiberglass batts. The tendency is to cram it up tight in there and have bellies and holes and things, but that all is going to cost you a little bit in performance. To maximize your performance with fiberglass bat insulation, the bats should be fully fluffed and fully fill every joist cavity. And you can see here, we've taken the fiberglass bats, pushed them up to the top, and then pulled them down slightly so everything's nice and flush and even. There's no holes or voids or anything like that. That can cost performance. It takes a little longer, but in the end result, you get a better product.
If I have a crawl space that has the risk for flooding or from high water table, the last thing I want to do is bring that crawl space indoors, so insulating the bottom of the floor joist as we're doing here would be my first preference.
Looking at this block wall, it's pretty clear that since it's been installed, it's had a history of moisture intrusion. We can see soils are wet along the perimeter. As we saw outside, the grade slopes towards the block, so when it rains, it's fairly common to have some water inside here.
For us, typically foundations in southeast Alaska only have the ability to dry to the inside. Our soils are saturated, so there's no drying to the exterior. What we need to have the ability is to have some dryability, and your best approach is to dry to the interiors. So if we were starting from brand new, it'd be perfect to waterproof the outside of the foundation and insulate to the outside of the foundation, protect the waterproofing with insulation, have a nice dry foundation wall to the crawl space and the drying potential. If we insulate this wall to the interior side now, we're going to reduce all that evaporation. So now we're going to store that water more so.
So it can't dry to the inside anymore if we put an impermeable layer over it.
Probably the only chance it could dry is to the top of the wall.
And then you'd run the risk of carrying moisture into the wooden framing. So in this case, that's our biggest reason for insulating across the bottom of the subfloor. There are other advantages too, but stopping that potential moisture travel up into here. So here we've got the first roughly 16 square feet of this floor done. Everywhere we knew we had holes in the subfloor, we went to the extra effort of sealing all of those holes up so that there was no pathway for air leakage to get up into the house. This here then provides us an additional level of air tightness. In this case, we're leaving the joints between the foam board unsealed. We've put them as tight together as we can. And the line of reasoning there, Markham, would be,
if anything, for some reason we had air or water getting into this subfloor from the living space, that it could find its way out. Okay. And that this is acting as a somewhat of an air barrier, not acting as a vapor barrier, but a thermal barrier, thermal break.
So we've sealed the really large air intrusion points here, but we've still got, a snug fit between the joints, but we're not going to tape them or seal them in any other way. So assuming that we've got the ground vapor retarder sealed everywhere and we've got all the foam installed across the bottom of the joists, except for one place, and that is a spot where we would install a humidistatically controlled fan. And the idea is this crawl space is now air sealed, the floor is isolated from this crawl space, and so the way we would ventilate it is to put a hole through the rim joist or use a place where we've got an existing vent and run the 4-inch duct for this fan out that joist area. And the typical code for ventilating mechanically a crawl space like this is 1 CFM for 50 square feet. So in our case, a 50 CFM would be a good choice. Markham, what would you say the humidistatic control on this fan should be set to?
60% is where I like to set that, Elia. I don't want any wood material to come, if I can help it, to hit 80%.
Okay.
So I look at, let's reduce it by 20%, 60%. It's very achievable. We've cataloged a number of crawl spaces for the last 20 years, and doing the insulation like we've talked about and shown here, and putting a mechanically vented fan in there, rarely will a crawl space exceed 60%. Well, I think one of the things that we should be paying attention to as we go to mechanically vented crawl spaces is knowing when the fan doesn't work anymore. You know, it'd be great to have a duty cycle light that said, the fan is kaput, right?
Yeah, so you've got a light somewhere where it's visible.
Yeah, and then
comes
someone
on.
knows, and there's no false security then, that you think you've got everything under control.
That's another good point, is it never hurts to stop down and look in here periodically just to see what's going on anyway. Here we've got a crawl space that's a work in progress. There's a completed 6 mil poly vapor retarder here. It's well sealed around the edges. We'll look at some of the details here in a minute. It's wonderful down here as far as the air quality goes. Even just looking at the lights, I can't see any dust particles floating around. So this is a beautiful crawl space in that regard. The block is dry, the joists are dry.
The contractor's taken time and has raked out all the rocks and the debris from the soil here and got it pretty smooth and made a safe environment to start laying this 6 mil poly. Just crawling around on this is quite a bit more of a pleasure.
So you can see here just how moisture gets trapped behind the concrete, wicking through from the ground. Now that it can't dry to the inside, that it's got the poly on it, it's a great example. This post was already anchored to the footing, so it wasn't possible to put a membrane underneath. So the next best option was to seal closely around it, just like this. But this is really well done as far as how it's trimmed and sealed. Someone took their time, did a nice job.
That's a nice job.
Yeah. Here we see a really nice cut-in patch around the main waistline coming from the house. I mean, this is a 4-inch ABS pipe, and every case is going to be different in how you have a penetration in the ground and what it is that's going in. So it's going to require some creativity. But the main thing is try to get everything sealed just like this to expose as little soil as possible. And I'd say this is just about as good as you could hope for here. We've got the water supply line coming out of the ground. It's got foam pipe wrap around it. There's another patch. There's tape sealed to it. Once again, there's no soil exposed whatsoever, so it's a very nicely detailed job.
So in completing this project, really want to put a piece of rigid foam on top of the mud sill in contact with the rim joist. This face will extend out so that when the wall foam comes up, it kind of locks it in like a keyway. So it keeps it nice and rigid. And then air sealing the same way we did with either acoustical sealant or one-part foam.
So then you've got continuous insulation starting from the bottom of the footing all the way to the top.
Yeah. You know, ideally we'd like to see R20 on the foundation wall. I mean, that would be our goal here. R20, now we have this small basement, how many thousands of cubic feet we're going to have, but we've insulated to the same level as our exterior walls. R20 for Southeast Alaska is about where we're shooting for above grade wall. Once we do get this wall completed, it's going to have very, very little drying potential at all. So making sure we take care of water management on the exterior side is going to be critical.
Good drainage, good sloping, all that. So in this case, it looks like they've opted to leave the insulation out from inside the floor joists and insulate the foundation walls around the perimeter. In terms of energy performance, you guys are in a warmer climate, so it's less of a concern as far as having floor insulation. You're more concerned with moisture management.
Moisture is number one for us. That's the one that kills our buildings as far as, reduced durability is moisture. Sealing it all up, water and vapor tight. I would expect this crawl space to perform really well. And, if this is where my breathing air is coming from in the house, this is quite all right for me.
Yeah, no, that's a really good point. As we've seen in today's video, crawl spaces in maritime climates are a particularly challenging problem, and there may be multiple ways you can deal with insulating and moisture issues. Sometimes it's better to insulate across the bottom of the floor, and in some cases it may be better to insulate the foundation wall. But in all cases, good moisture management starts outside the building first. If you've got good gutters and proper drainage, and ideally also good foundation waterproofing, you're really limiting the amount of moisture that gets in to begin with. Then inside the crawl space, you certainly want to have a good ground vapor barrier. And at some point, every crawl space may benefit from mechanical ventilation. So if you get some high humidity down there, you'll have a way to deal with it before it affects building durability and the indoor air quality above in the living quarters in the house. And if you've ever got heavy rains or you haven't been down to that crawl space in a while, it never hurts to check and see what's going on.